Enzymes are used to decrease the activation energy of reactions, which in turn speeds up reactions from reactants or substrates to products. The equation used to demonstrate an enzyme-catalyzed reaction is enzyme plus substrate goes to enzyme-substrate complex, which goes to enzyme plus product. To demonstrate the ways that 4 kinetic parameters can affect reaction rates, I will be modeling the marble transfer reaction. Here is the setup for this demonstration. You will need 2 boxes to represent the beginning and end of your reaction, marbles, which will be your substrates, a timer to time the rate of product being formed, and a blindfold, which will prevent the enzyme, which is me, from easily seeing the substrates during transport. Some rules to keep in mind are making sure to only transport 1 marble at a time, use only 1 hand unless specified to do otherwise, use the blindfold appropriately to cover your eyes, and keep your hands at a constant speed when transferring to prevent results from being skewed. First, I'm going to demonstrate the normal enzyme-catalyzed reaction to show you the different parts of the reaction. You start off with enzyme plus substrate being separate. Then, as I grab the marble, we become the enzyme-substrate complex, showcased by having the substrate in the enzyme's active site, which is my hand, which in turn becomes the enzyme-substrate intermediate as I move my hand toward the other box. This intermediate becomes the enzyme product complex, and when I finally place this complex into the right box, it becomes separate enzyme plus product. Now that the equation is clearly shown, I will demonstrate parameters that may affect this reaction. The first demonstration is varying substrate concentrations. These videos show a substrate concentration of 4, 7, 10, 20, and 30 marbles. After recording the amount of product that was made, it was concluded that with an increase in substrate concentration, there was an overall increase in the amount of marbles transferred in 10 seconds. However, after a certain amount of substrate concentration was reached, there wasn't much variability in the amount of marbles transferred in 10 seconds as the substrate concentration surpassed this. This Michaelis-Menten plot demonstrates the results, which shows that we have a Vmax of 8 and a Km of 4. As we increased concentration of substrate, the reaction rate increased until saturation was reached at 8 marbles being transferred. The next demonstration is varying enzyme concentrations, demonstrated by different amounts of hands used. For this, I recruited my roommate Laurel, who acted as a 3rd and 4th hand, showing an increase in enzyme concentration. Adding more enzyme increases the rate, which corresponds with more marbles being transferred. In addition, saturation is met as well. Shown in this plot, we see a Vmax of 12. However, the Km wasn't present due to one enzyme still being able to transfer more than 1/2 of the Vmax. Another important kinetic parameter that needs to be taken into account is kcat. Kcat is the turnover number, which tells us the amount of product the enzyme can produce per second at saturating conditions. The limiting aspect of this experiment is that I can't move my hand at a faster speed, especially when blindfolded, which tells us how the kcat remains constant throughout the process. Due to this, based on this equation, we know that since kcat is constant, then the only thing affecting the maximum rate is the enzyme concentration. In addition, the kcat isn't dependent on substrate concentration due to the saturation that is eventually met in the scenarios demonstrated, and how the kcat is solely telling us how the amount of product changes due to the presence of an enzyme rather than with increasing substrate concentrations. The Km value represents the amount of concentration that it takes for 1/2 of the Vmax to be reached. The Km solely relies on the Vmax and how many marbles per 10 seconds are transferred. Due to this, the Km doesn't rely on enzyme concentration because the Vmax is the point where the enzyme is maxed out, which makes Km a constant. All in all, I hope this marble transfer representation demonstrated clearly some of the kinetic parameters that relate to reaction rate.